so we're starting the day 7 video today, and today we're going to be talking about a whole bunch of different random things. So the covalent network compounds. So the first thing you need to understand is covalent compounds are not always these perfectly isolated structures. They can, like a lot of different ionic compounds, form networks. So as you see here, this is silicon dioxide. This means that for every one silicone that you find, there's going to be two oxygens bound to it. So even though there are many silicones and many oxygens found in this structure, if I took all of those and I tried to simplify them to their smallest number, I would see that for every one silicone, there are 2 oxygens. And it's named in basically the same way that we were talking about yesterday. If there's one silicone, it's silicone, 2 oxygens, it's dioxide. We have another one, silicon carbide. This means that for every one silicone we have, there is 1 carbon atom, okay? And it's also found in a network like this. And the network goes on and on and on. It doesn't really just end here. Then we can have trisilicon tetranitride. Basically, this means that we have, for every 3 silicones, we have 4 nitrogen atoms that are bound to it. Okay? So remember, covalent compounds, like ionic compounds, some of them can form networks of atoms that come together. In fact, there's a lot of commonly known ones like diamonds are a network of carbon atoms that are bound to each other in a specific way, and they form a gigantic crystal like the diamond, right? All right, so now we're going to talk about acids and salts. You guys have probably heard about an acid. You know that an acid is a substance that when it touches your skin, it has the ability to burn you. They're used in a lot of useful ways in labs. So we got to talk a little bit about naming these acids. We have 2 different types of acids. We have binary acids and oxyacids. And I'm sure from the name oxyacids, you can kind of determine what that means. It basically means that it's an acid that contains an oxygen in it and at least a couple of hydrogens. A binary acid is actually the easiest one to name. It's basically an acid that contains a hydrogen and a halogen. So a halogen are group 17 in the periodic table. You have fluorine, chlorine, bromine, iodine, and if they're combined with 1 hydrogen atom, you get hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, right? Super simple naming the binary acids. Oxyacids, on the other hand, are a little bit different. So if you look here, here are all of the binary acids, hydrofluoric, hydrochloric, hydrobromic, hydroiodic acid, right? And they all end with acid. Now, when we talk about oxyacids, basically what we're showing you here is a polyatomic ion that is bound to a hydrogen, okay? So this would be like nitrite and nitrate, and when they're bound to a hydrogen, they turn into an acid, okay? So phosphoric acid, PO4, would originally have had a negative charge, and it would have been phosphate. But as it becomes bound to hydrogen atoms, it loses its charges, and it becomes an acid, right? So these are just different examples of oxyacids. So we have nitrous acid, nitric, sulfurous, sulfuric, acetic. You guys probably know this. This is just regular old vinegar. It's not very strong. So not every acid is actually going to kill you. If you look at here, this is carbonic acid. Carbonic acid is the stuff that they put in your soft drinks to make those fizzy bubbles. And the reason those bubbles show up is because the carbonic acid gets turned into carbon dioxide. And that carbon dioxide, as it leaves the solution, forms the bubbles because carbon dioxide is a gas. But you get the idea. Binary acids are just a hydrogen with a halogen, while oxyacids are acids which contain at least 1 hydrogen and at least 1 oxygen. Okay? So, what we need to know in the lab, in terms of the term acid usually refers to a solution in water of an acid compound rather than the acid itself. This is why, by the way, they're called hydrofluoric acid. You guys know what the word hydro comes from. Hydrate. Hydro means water. So we call it hydrochloric acid because we're not actually talking about HCl. We're talking about HCl when it is mixed in with water because that's when it becomes active and it starts to actually interact with different things. So, many polyatomic ions are produced by the loss of a hydrogen atom from an oxyacid. So if I look over here at this oxyacid, sulfuric acid, if it loses its two hydrogens, it will become a sulfate ion. You guys remember these from this table back here? These are your polyatomic ions, right? If I add hydrogens to these, they will turn into acids. And if the acids lose hydrogens, they will turn into ions. And this is just because hydrogens carry, in general, a charge of +1. So when I add a hydrogen to acetate, it becomes acetic acid because that +1 charge of hydrogen came in and canceled out this negative charge of acetate. So as you can see here, the sulfuric acid gets turned into sulfate when it loses its hydrogens. Nitric acid gets turned into nitrate when it loses its hydrogens and it gains a charge of -1 because as you can see, for every hydrogen that it loses, it gains a charge of -1. So phosphoric acid, when it loses 3 hydrogens, it becomes phosphate with a charge of -3. Sulfuric acid, when it loses 2 hydrogens, it becomes sulfate, which has a charge of -2. See? Very simple. So basically what happens when you drop an acid into water is that these hydrogens leave the acid and they go and bind with the water molecules. So then they create different substances inside the water. If you take the acid, as you can see here, how there's a little white and a little red together, this is your acid. So let's say this is hydrochloric acid. Maybe the red is the chlorine and the white is the hydrogen. As soon as they enter the water, the hydrogen and the chlorine separate from each other. So now you have a negatively charged chlorine swimming around and a positively charged hydrogen, which is ready to go and react with anything that it can find, right? All right, so many polyatomic ions are produced by the loss of a hydrogen. So as you can see, this is the same table from the previous slide. So the last thing we need to talk about is a salt. Like we said earlier, an acid is basically polyatomic ion with a hydrogen attached to it that has no charge overall, right? A salt is basically anything like NaCl, which is table salt that you have at your table every day. It is basically just another name for an ionic compound because it's a combination between an ion, a cation, and an anion that are bound to each other. Okay? So salts are just ionic compounds. Now there's a way that we can make salts using acids and bases. We are going to get a lot deeper into this when you get to grade 11, so don't get too confused by this, but basically when you do this type of reaction, you end up creating a salt because you free an anion and you free a cation from their original compounds, and when the anion and the cation come together, they form an ionic compound, which is also known as a salt. And if you can see here, there was a hydrogen and an OH. H2O makes a water molecule. We're going to get a lot deeper into this in later years. That's the basics. We don't expect you to know very, very deep into this whole acid-base type of thing. We just want you to get the basic idea that you can form salts by combining positive and negative ions, and if you take an acid and you remove its hydrogens, it will become a polyatomic ion. And if you take a polyatomic ion and you add hydrogens to it, it will become an acid. Okay? All right, so now guys, of course, if you have any questions, let me know. And if you're okay, good for you. Good luck.